Today we're going to look at functions. Let's start filling in the notes. Your first blank there is a relation. A relation is a set of ordered pairs, and a relation can be represented using a table, a mapping diagram, a graph, or I can just list them as ordered pairs. So a relation is just a set of ordered pairs. I've got an example below of 1, 4, 2, 3, and 6, 5 is shown here as ordered pairs right there. But we can also represent it these ways, like listed above. I could show it in a table. You can see right here, that's 1, 4, ordered pair, then 2, 3, and then 6, 5. You're familiar with the table. I can also use what's called a mapping diagram, where we put our X values in one bubble, the Y values in the other. You list the numbers least to greatest in your bubbles, and then you draw arrows for how they're connected, like the ordered pair 1, 4. 1 has an arrow going to 4. 2 has an arrow to 3, and 6 has an arrow going to 5. So that's showing those ordered pairs that way. And the last one is a graph. This is 1, 4. There's 1, 4 on our graph. Here is 2, 3, and back here is 6, 5. So just different ways we can show ordered pairs, which is also called a relation. Now today's lesson is about functions. A function is a relation, but it's very special. Only certain relations are good enough to be called functions. So functions are special relations in which each input is paired with exactly one output. So let's talk about that as well. When I say input, I mean your X values, and output, I mean your Y values. So this says each X value is paired with exactly one and only one Y value, okay? So let's look at example number 1. Which set of ordered pairs represents a function? So the first line there, -7, 5, -9, -4, -3, -1, and -3, 4. Okay, so as I look at it, -7 is paired with 5 in that ordered pair. Okay, -9 is paired with -4. -3 is paired with -1, but look at this last one. -3 is also paired with 4. -3 was paired with -1 and with 4. -3 is paired with -1 and 4. The definition of a function is the X value is paired with only one Y. In this first set of ordered pairs, this first relation, it's paired with two things. That's not right. That's not a function. Let's look at the second list. 5 is paired with -3. 1 is paired with 2. Wait. 1 is also paired with 8? No. 1 can't be paired with 2 and 8. 1 is paired with 2 and 8. Ruh-roh. Okay, it's still a relation, but it's not a function. Third one, -5 is paired with -1. 9 is paired with 7. -2 is paired with 6, and -3 is paired with 7. How do we do? I think we're good. Let's look at one more. Let's look at the last one. -2 is paired with 9. -2 is also paired with 6. Let's see, 1 is negative, this one. Okay, here we go. We can't have that. -2 is paired with two numbers. That's not a function. It's paired with 9 and 6. No. So the one that is a function is this third one. And notice how I wrote it out and I circled those X's when they repeat it. So if you have a list of ordered pairs, if you're trying to determine if something's a function, a quick way is checking your X values. And in a function, the X values can't repeat. Your X's can't repeat. If you look at the X's, if you see them happening twice, just nope, you're done. So instead of looking and reading every ordered pair, I could have just compared the x values. It really doesn't matter what the y values are. As long as our x's aren't repeating in the list, then I know it's not paired with more than one y. Okay, so you can just check your x's, make sure your x's are not repeating. They cannot repeat. That is what makes a function. Our next two examples, we're going to look at those mapping diagrams. In number 2, set A is mapped to set B. This is like our x values and our y values. So from our mapping diagram here, this is 6 is paired with 1. I've got 7, and the arrow goes down to 5. So 7, 5 is like an ordered pair. -3, 4, and 9, 1. See how that works? Okay, it's just a different way to represent our relations. Using what we did above, did any of my x's repeat? 6, 1, 7, 5, -3, 4, 9, 1. Did any of these numbers happen twice? No. So this is a function. Yay, it's a function. So on Delta Math, you are going to fill out several drop-down boxes. I've given you the options here on the notes, or there's a couple places I bolded, the set A and set B. I bolded those. Those are also drop-down lists for you on Delta Math, but those are always those. Those are the places you will always choose those answers. All right, so let's fill this in below. It says the mapping diagram above, you're going to choose represents a function, since for each number in set A, the input, and that's bolded because that's also a drop down or a choice on your Delta Math, but that one is always going to say set A, the input. You're always going to choose that one, okay? So one less one to get wrong, just know that one is always set A, the input. For each number in the input where there is only one mapping to set B, the output. Again, set B, the output, I put it in bold because it's also a place that you choose on Delta Math, but that's always the answer. So let's check it again. The mapping diagram represents a function since for each number in the input, there is only one mapping to the output. Each x was paired with only one y. Let's look at number 3. Our set A mapped with set B. Our ordered pairs look like 8, 3, 8, -4, hint, wink, cough, cough, 7, 9, and -3, 9. Now, what do? We check and see are our x's repeating, and absolutely, x's are repeating. X's repeat, therefore it is not a function, sad face. So let's fill in the choices. The mapping diagram above does not represent a function, since there is one number in the input, that 8 value, where there is multiple. There are multiple mappings from 8 to the output. 8 is mapped to 3 and 8 is mapped to -40. See that? The mapping diagram above does not represent a function since there is one number in the input, 8, where there are multiple mappings to set B. 8 goes to 3 and -4. So those are your choices there. Let's do 2 more just like that. Number 4, your x's to your y's are mapped. This is 3 is mapped to -4. You have 2 is mapped to 8. -3 is mapped to 4. So I'm checking out my x's. Everything looks good. I believe this is a function. Each x is paired with only one y. The mapping diagram above represents a function since for each number in the input, there is only one mapping to the output. Number 5, your x's and your y's are paired. 6 is matched with 8. 6 is also mapped to 0. 2 is mapped to 4, and 3 is mapped to 5. Where did we see it? X is repeated. Therefore, this is not a function. Sad face. Let's fill in our blanks. The mapping diagram above does not represent a function since there is one number in set A, the input, where there are multiple mappings to set B. 6 went to 8 and 6 went to 0. It went to multiple places in the output. The last type we're going to look at is the graph. So at the very beginning of the notes, we said a relation can be shown as a table, ordered pairs, a mapping diagram, and a graph. And we still want to determine whether a relation is special enough to be called a function. So the quickest way you can do this is with the vertical line test. Vertical line test. Remember, vertical is up and down. So I'm going to take a vertical line. You can use your pencil, you can use a piece of paper, you can use anything, put it up and down, and we are going to slide it across our graph. And if it only touches once, if our graph only touches once, then it is a function. If our vertical line touches our graph more than once, it's not a function. So if I was to take a vertical line and place it anywhere on this graph, so even if I start on the left side, it's only touching once. That's good. Woohoo! If I keep sliding it, and I wish we were in class together, I could show you. Keep sliding it, still only touching once. It's still only touching once. Keep moving it all the way across. It's only going to touch once. So this is looking like a function. Now, maybe you're curious about that piece right in the middle. Let me zoom in real close. Maybe you're curious what's going on right here. Okay. It is getting really steep, but I promise it's not steep enough to mess up our vertical line test. It's good. I promise. This is a function. And Delta Math does a great job. If you look at their examples, they have like an in motion vertical line, and they can show you that it's only going to touch once on this graph, and therefore it's a function. Okay, vertical line test, once, function. Look at number 7. Number 7, you've got that sideways kind of curve, looks like a C, looks like a sideways parabola there. If I was to draw my vertical line almost anywhere along this, you see how it's hitting twice, top and bottom, no matter where I put it, top and bottom, even way over here. It's hitting twice. This one is not a function. When I do the vertical line test, it's hitting 2 places. What does that mean? Ms. Bryan, I don't get it. What does it mean? Well, if I was to label these ordered pairs, I would have ordered pairs like, let's just say that's 3, -1, and 3, 3. I know that's not exact or anything, but I would have an x of 3 paired with -1 and 3. My x's would repeat because I have 2 points that are above each other vertically. Okay, not a function. The last one, if I draw my vertical line once, that's good. Once. Okay, looks good, right? But a lot of you are going to be curious, well, what's going on here? What's that doing? Ms. Bryan, I'm confused. So right there is an invisible boundary line where this graph's getting closer and going up, and then it gets closer and closer going down. To me, this is the only like weird one that you're going to see on Delta Math. The other ones are pretty obvious, but I wanted to be sure to put this one on your notes. This one is a function. The one side is getting closer and closer, and it microscopically is inching out as it goes up, and same with the other side that's going down. It's microscopically inching out as it goes down. This is still a function. So again, I wanted to make sure to put it on your notes so you had that. It is a function. It is a function. I promise. Don't get caught up on that one. Again, put it on your notes for a reason. I think all the other types of graphs you're going to see on Delta Math are fairly obvious. When you draw that vertical line or you drag it across, once is a function. If it hits more than once, it's not a function, because you can't have 2 x ordered pairs vertically, because that would be like we wrote on our notes, x 3, -1, and 3, 3. Your x value is repeating there. All right, so recap. So a relation is just a set of ordered pairs, but really cool relations are called functions. And you get to be called a function if your x values or your input is not paired with more than one y, which when we list them out shows up that my x's are not repeating. Not repeating function. So you can use that with list of ordered pairs. You can use that when you're looking at your mapping diagrams. Like I showed y'all here, I like to list my ordered pairs when I'm looking at that mapping diagram to help me see that visual. And then with your graphs, you can use the vertical line test. Drag a vertical line across your graph. If it's only touching once, that's great. It's a function. If it touches more than once, then it's not a function. Practice those. You're just identifying whether they are functions or not. Try them out. Let me know if you have questions, and I'll be glad to help guys. See you in class.